Hi, this is Rodolfo Eric Angat, your teacher in Earth and Environmental Science. Today we'll be learning about Barycenter. Our essential question for this lesson is, how is the barycenter affected by the masses of objects covering standard 1.1.1? In this lesson, we aim to achieve the following targets. The first one, I can define barycenter. The second one, I can locate the barycenter of the Earth and the Moon. The third one, I can locate the barycenter of different celestial bodies with different masses. And finally, I can explain how astronomers locate planets that are not visible. Let's begin by defining barycenter. Barycenter is the point between two objects where they balance each other. It is the center of mass, or it can also be the center of gravity. This is where two or more celestial bodies orbit each other. Unlike before, we used to say that the Earth revolves around the sun or the Earth orbits around the sun. But nowadays, we say the Earth orbits around the barycenter of the solar system as all the planets, including the sun, do. They all orbit around the barycenter or the center of mass or the center of gravity. The barycenter is always near or closer to the more massive object. So you would expect that the barycenter of the solar system is very close to the sun because the sun contains 99.8% of the mass of the solar system. So it is the most massive object. We can simulate barycenter by doing the figures shown on the screen. So you can have a dowel and two things attached to the end of the dowel like clay of the same mass and then a string that's attached to the ceiling, and you will find out that if the masses of the two objects on both sides or both ends of the dowel have equal masses, then the barycenter would be in the middle. If this one has a bigger mass, then the barycenter would be closer to this place here. And if this one is the one with the bigger mass, then the barycenter will be closer to this one. Just to review, the barycenter is always closer to the more massive object. And the barycenter is also known as the center of gravity. Now, the barycenter or center of gravity, as you can see here, this object here has a bigger mass than this object here. Thus, the barycenter is closer to the bigger object. How about the barycenter of the solar system? The sun's center of mass is deep inside the sun itself. But the planets do not revolve around the center of mass of the sun. Rather, the planets revolve around the barycenter. In this case, it is between Jupiter, the biggest planet in the solar system, and the sun. The barycenter of the two is located closer to the more massive object, which is the sun. So this means that the sun itself revolves around this barycenter, and Jupiter also revolves around this barycenter. And this is how we show it. This object in the middle here represents the sun, and it is circling around the barycenter of the celestial bodies. As this object too is circling around the barycenter of the celestial bodies. How about the Earth-Moon barycenter? Let's watch part of this video so that we would understand how the Earth-Moon barycenter goes. Besides, that's one of our targets, right? Though we often say that the moon orbits our Earth, it is more accurate to say that both actually orbits their common center of mass, and that is called the barycenter. The barycenter of the Earth and the moon is actually inside the Earth. It's right here, and it's closer to the surface than to the center. Earth revolves around the barycenter, and the moon does the same thing. That barycenter of the Earth and the moon is the reason why Earth is wobbling as it orbits. And we will be discussing about this wobbling when we reach the lesson on precession. That is the barycenter. That barycenter is about 1,710 kilometer beneath the surface of Earth. We will go to the next one now. The barycenter is located, just like what I said earlier, 1,710 kilometers between, or rather below, the surface of our planet. So the barycenter of the Earth and the Moon is not in the center of Earth. It's actually closer to the surface at a depth of 1,710 kilometers. Some internet sites would say 1,700 kilometers. Some would say 1,715. Just kind of remember, in our learning, we remember the 1,710 kilometers. How about the barycenter of the solar system? Let's see this one. The solar system's barycenter is very close to the sun, but not at the sun's center. Let's watch a part of this video. You can watch the complete video when you have the time to do so. Though we often say that the planets orbit the sun, it is more accurate to say that the sun and all the planets actually orbit the center of mass of the entire solar system, a point known as the solar system barycenter. This is the sun right here, and as you can see, the sun is also spinning. As it spins, it also revolves or orbits. Where does it revolve? Where does it orbit? It orbits or revolves around the barycenter of the solar system. There it is right there. It goes around this one. So the sun is also wobbling just like the Earth. All the other planets also orbit around this barycenter of the solar system. So remember, our star, the sun, also orbits and also spins. Or we can say it also revolves and it also rotates. And here are the other planets revolving around the barycenter of the solar system. Okay? Again, now we say that the Earth revolves around the barycenter of the solar system rather than saying that the Earth revolves around the sun. That is just a simplification. As you can see here, it says here 1,700 kilometers. This is the Earth-Moon system barycenter. Just like what I said earlier, we will be remembering the 1,710 kilometers from the surface because this is the one that will be asked in your NC final exams. The gravity is the one that is pulling each other. Like Earth is pulling the moon and the moon is also pulling the Earth. Of course, the gravity of Earth is far greater than the gravity of the moon because the mass of Earth is far greater than the mass of the moon. The gravity of the moon is about 17% that of Earth. So if you weigh 200 pounds on Earth, you will weigh about 34 pounds on the moon. This gravity is also the reason why we have tides. When we discuss about tides, always remember that gravity is the reason why we have tides or the rising and falling of the water on Earth. Gravity. And the moon's gravity is mainly responsible for these tides. That's the barycenter again. Object 1 revolving around the barycenter, and object 2 is also revolving around the barycenter. Now let's have some assessment. Identify the location of the barycenter. Is it A, B, or C? Okay, the correct answer is B. So this is the barycenter. This is where object A and C revolves. This is the point where they revolve. How about this one? Identify the location of the barycenter. Is it A, B, or C? The location of the barycenter is C, because this is more massive than this one. So the barycenter is always closer to the more massive object. At a certain point, it is even inside the more massive object. How about this one? Identify the location of the barycenter. Okay, so the correct answer is A, because this is the more massive object. Remember, the barycenter is always closer to the more massive object. How do the barycenter help astronomers find other planets, moons, or even stars that are not visible with telescopes? The barycenter causes the planet or the star or any other heavenly bodies to revolve around it. And this revolving causes the heavenly body or the celestial body to wobble. This wobbling caused by the gravitational pull causes the star to twinkle, to cause some changes in brightness. The, the, the changes in brightness and the wobbling is a telltale to astronomers for them to know that a planet or another star is hiding. Like in some solar systems, there are two stars. They're called binary systems. Sometimes you won't see the other star because the first star is so bright or their brightness mixed together. But if you see that the star is wobbling, then that is a sign that there is another star trying to pull that star, and that is a clue that the system is a binary system. Okay? So just like Earth, Earth is wobbling because the moon is there. That is also how they find the moons of other planets. If the planet is wobbling, then there is a certain object close by, or a certain celestial object close by that is causing it to wobble, and that makes them say or hypothesize that there is a planet, and with that, they try everything to find it. Okay? So that's the barycenter or the center of gravity. Okay, so I hope you are now confident in answering the questions. Good luck in learning. Thank you so much. Bye-bye.